So what's going on here? The difference in the last lesson, from the last lesson, is one equation is going to be in gradient-intercept form, and the other one's going to be in standard form. And we want to solve for x and y. So we're solving for a point. We're solving for x, y, which will be the point of intersection of the two lines, which we're not graphing. We're going to be doing it with algebra instead. So let's look at example 1. Okay, intersection with a C there. First example, that's standard form. That's gradient-intercept form. And there's a number of ways I can do it, but the main way we're going to solve this one is by a method called substitution. Substitution method. Now in algebra, substitution can mean a lot of things. It means we can replace a variable with a letter. No, replace a variable with a number. It also means I can replace a variable for an expression. So anytime you've got mixed form, standard form and gradient-intercept form, we're going to substitute y, this y, for this expression. So basically, I'm taking this expression and cramming it in for y in that other equation. Now when I do that, I rewrite this top expression, top equation. So 2x plus y is no longer y, it's just x minus 5. And you can see that solving for x isn't too hard from here. 2x plus x is 3x, minus 5 equals 4. So I'm going to add 5 to that side and then divide by 3. 4 plus 5 is 9. And then x equals 9 divided by 3. X equals 3. And now, like the other example, we take that 3, the other video, we take that 3, and we're going to substitute it into the gradient-intercept equation, because that's the easier equation to solve for y. So x is now 3. 3 minus 5 gives me negative 2. So my point of intersection, of course, is 3, negative 2. Okay, let's look at another example. Okay, let's look at this example. Sorry about that mistake there. Recognize that we're going to solve by substitution. Take that expression for y equals 5x, and I'm going to substitute it in there for y, but you have to be careful because what we're saying is we're subtracting that 5x, and that's going to give me 3. And I say be careful because when I simplify this bit, that'll give me a negative coefficient. 2x minus 5x is negative 3x. And then I divide by negative 3, which gives me negative 1. And I take that and substitute it into the equation that has y by itself. Not that equation, this one. So y equals 5 times negative 1, which means y is negative 5, of course, which means my point of intersection is negative 1, negative 5, much quicker than graphing it. Next example, we're going to have y equals x plus 2, and 2y equals 5x minus 2. Now I chose this example because this isn't necessarily standard form, but we're still going to be solving it with the substitution method. This is gradient-intercept form, but hopefully you can see that you're still going to take that expression for y that it equals and substitute it in right there. So when I rewrite this equation, it's 2 brackets x plus 2. We have to put brackets around there, so the 2 multiplies to everything in there. 5x minus 2. Expand. 2x plus 4 equals 5x minus 2. Switch these two terms around, changing their sign. 2x minus 5x equals negative 4 minus 2. 2x minus 5x is negative 3x, of course. Negative 4 minus 2 is negative 6. So when I solve for x, it's negative 6 divided by that coefficient, which is, running out of space, 2. Finally, I'll take that 2, substitute it into the equation that has y by itself. 2 plus 2 is 4. So my point of intersection for that one, x equals 2, y equals 4. Finished. Let's have a round of applause there. Good job. Good job.